Okay, sir.
सर झालं recording start?
नाही आणखी मेसेज नाही आला.
Not it.
Yes,
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 yes.
Yes, started. Great.
So very good afternoon to one and all present here. So I'll start, right?
Tanya, make your camera on.
Okay.
Yes, perfect.
I'll start now.
Yes, yes.
So a very good afternoon to everyone present here. I, Tanya Hinduja from TCOM, welcome you all to this workshop on machine learning, deep learning and its applications, held under the innovation activity of MESCO IIC. Today's session will be conducted by Suraj Gawande sir, who serves as a senior engineer at MATLAB technical team at Design Tech Systems Private Limited, where he is leading as the region where he is leading the region of Maharashtra, Goa, and Mumbai. He has an expertise in the areas of image processing, machine learning, deep learning, and data science. He brings with him a total of 4 years industry experience. Prior to working in Design Tech Systems Private Limited, he worked on platforms of Xilinx, LabVIEW, and Texas Instruments. He has completed his master's in 2017 from Pune University and has published total 5 papers in areas of machine learning, deep learning. It is an honor to have you, sir. I would now like to request sir to take it over from here to begin today's workshop.
Yeah, thanks Tanya for such a nice introduction and good afternoon everyone. Yeah, let's get started. The objective of today's presentation is to make you aware on MATLAB platform for machine learning and deep learning applications. So I'll be taking you through introduction to machine learning using MATLAB, the concept of machine learning, and how we can implement machine learning algorithm using MATLAB and Simulink. And we'll also talk about how deep learning frameworks are useful for classification of various types of data. So that is the agenda for this presentation. Yep. So let me share my screen and you guys can let me know when it will be visible for you. You can type in chat box like yes or no. Yeah, is it visible for you?
Yes, sir, it is visible.
Yes, sir.
Visible, right? Yeah.
Sir, it's visible. Yes.
Yeah. Thanks for the feedback.
Yes.
Uh, we know human can learn from their past experiences and machine follows the instruction given by the human. So everybody present in this meeting agreed with this two statement that being a human, we understand from our past experiences whether to commit same mistake again or we should, we can go ahead with certain activity. And machine follows the instruction given by the human. That is also correct, right? So we have so many devices with us like a mobile phone or washing machine or electronic control devices. So those are the machine, those are the devices which follows the instruction that we supposed to give through some controlling unit. What if human can train the machine to learn from past data, which means whatever, like being a human, whatever I learn in my day-to-day activity, so whatever I learn, if based on the same knowledge, what if I train the machine, what if I train the machine, so what will happen? Machine can act much faster than human because machine doesn't have emotion like human. Machine can act 24 by 7 without any tiring situation. So that there are a lot of advantages of replacing machine or the humans to perform certain activity, and that's what is machine learning is all about. To understand in more detail about machine learning, let's take an example, which is a real-time example we can say. Suppose his name is Paul and Paul loves listening music. So what he's doing basically, based on the input song, either he liking or disliking the song. Yeah, but then definitely there has to be a criteria on which he will perform his decision making. and those criteria is going to be tempo, genre, intensity, and gender of voice. So based on these 4 parameters, Paul will decide whether he will like or dislike the song. So what we'll do, we'll have to, we'll go with, we'll go to Paul, and we'll ask him to give a knowledge of around 100 songs, and we will classify those songs manually into 2 categories, that is like and dislike. Let's say Paul gave us the data of 100 songs, and out of 100 songs, 70 songs belongs to a like category and 30 songs belongs to a dislike category. So we have four parameters, that is tempo, genre, intensity, and gender of voice per sample, per song. So what we'll do, we'll try to plot a scattering plot. Since it's a 2D scattering plot, we cannot consider four parameter, and that's why I have considered only tempo on x-axis and intensity on the y-axis. So my tempo is varying from relaxed to fast, and my intensity is varying from light to soaring. Yeah. So based on that, I have 2 clusters, as you can see on my screen. One cluster belongs to a green category, which is a like category, and another cluster belongs to a red category, that is a dislike one. So based on the information I received from Paul, I could plot a data in such format that I can, I can say these are the songs which belongs to like category, and these are the songs which belongs to a dislike category. So what we'll do, we'll try to do some decision making just by plotting a data point. Yeah, when my data is quite linear and simple. So I'll take song A. Song A has fast tempo and soaring intensity. Song A has fast tempo and soaring intensity. So if I plot that song in the in the existing scattering plot, that song A is already lying in a circle where I have my all green samples. Yeah, which means in such cases, the decision is quite simple, which means just by observing the data points, I'm able to decide that the Paul is going to like the song. Yeah, decision is very simple for linear data. Suppose I'm taking song B, that's a new song, and song B has values like medium tempo and medium intensity. Yeah. And if I try to plot that song in the existing scattering plot, that song B is exactly coming in between these 2 circles. But then, can I, just by observing the data point, am I able to recognize it? Am I able to classify it? No, right? Because the decision is quite complex. It is neither into red nor into green. So in such cases, we have to perform some mathematical operations on this data to predict the output for song B. And that's where machine learning comes in picture. Or I can say I can make a use of machine learning algorithm to perform a decision making. What if I'll choose one machine learning algorithm out of the list is available, and suppose I'm selecting a k nearest neighbor, which is a supervised machine learning classifier. What is supervised? I'll let you know later on. So I'm applying a supervised machine learning algorithm on this data, and in the output I'm getting third circle plotted around song B. So I'm getting new circle plotted around song B. Yeah, as you can see on my screen. So in that new circle, I have 4 green dots and only 1 red dot. So I have 4 green dot and only 1 red dot. So which means here machine learning algorithm is going to predict that Paul is going to like the song because majority is from green circle, sorry, green color. So machine learning will say Paul is going to like the song. Then we have to go to Paul. I'll ask Paul, did you like song B? If Paul says yes, I like song B. In that case, my prediction done by machine learning algorithm is green, and what answer I received from Paul is also green, which means both are matching with each other. Which means the machine learning prediction is 100% accurate, and so machine learning algorithm is well suitable for song classification data. And that's how we have to implement machine learning algorithm using MATLAB, and we can take it ahead on hardware if you want to implement AI, that is artificial intelligence. Quite easy, yeah, right? But then the most important part is how will I import data, how will I develop model, and how will I train my machine learning model on this data to get some decision making done in the output. This is very important in machine learning, and same the same criteria goes with the human. If I'm teaching machine learning subject from last 5 years, I have to be a knowledgeable person. My all concepts should be clear, which means I'm an experienced person for teaching machine learning topic to the new batch of students in my college. That's what. More data is your experience. Better model is yourself that I have experienced. I am a better model for teaching machine learning topic, and in the output will be getting the accuracy. So which means if I have data, if I have more data, I'll have more experience, and accordingly, my decision making will be the most accurate in the output. And that is all about machine learning. And that's a slogan we can say. You should in your life. So machine learning has three different flavors: supervised learning, unsupervised learning, and reinforcement learning. So what is meant by these three? Let's go through it. Let's understand what is meant by supervised machine learning. To understand that, I would like to take one example here. Suppose your friends gives you a 1 million coins, and it's a very huge amount, I must say. So out of that 1 million coins, I have that coins data has been split down into three different three different currencies. A coin of and there's one more thing, that each coin is having some weight value, which means I have a coin, I have a 1 million coin, and each coin is having some unique weight value. A coin of 3 grams is a rupee, that's a currency. A coin of 1 euro is, sorry, a coin of 7 grams is a 1 euro coin, and a coin of 4 grams of weight is a 1 dirhams coin, which means I have rupee, euro, and dirham, three unique currencies throughout 1 million's data, and the 3 grams, 7 grams, or 4 grams are the input features that we have. Yeah, so at this for this data set, weight is the input feature and currency is the label, and this is a supervised so this is a label data. So whenever we have a label data, we go for supervised machine learning, where we perform a decision making, where we perform a classification on known data. So what we perform, we have 1 million data, right? So we split that 1 million data into training data and testing data. And once we have trained model on training data, we take that model for testing. So testing means it is similar, like being a student, I will write down a paper for control system. I submit my paper to the examiner. Examiner will check that paper. He will check that paper. Checking means a testing. He's testing you on your experiences, on your knowledge, that how much you have done preparation for so and so subject, on control system subject. So when you're writing a paper, which means you're training your, you are giving all your efforts to, give your best performance. And once that, writing and training is done, if someone is testing you, and he's giving you some rating, some marks in the output. That's called testing. So when we are testing the model, we are providing some unknown sample. So unknown sample means we'll only provide a coin with 3 grams ka weight. So I say to my model, here is the coin with a weight value 3 grams. Now tell me the currency. Now if my model says a currency is rupee, which means I'm getting 100% classification accuracy in the output. But if that model says no, it's a dirham coin, which means I'm getting misclassification done. And that is all about supervised machine learning. We work on label data and we perform training and testing. So basically training and testing is a common term in all types of machine learning models, be it supervised, be it unsupervised, be it reinforcement. But what is most important? Training phase. If I'm studying if I'm studying a control system subject very well, which means I will be able to solve all the questions in my in my final exam. If I'm not studying well, I will not be able to write down a paper. I'll get low score. It is exactly like that. What is meant by unsupervised machine learning? We have a cricket data of various players, yeah, and for each player, like in that data, we have three columns basically. The first column is name of the cricketer, like name of the player. Second column is scores, like how many score that's so and so player has achieved, and then third column is wickets, how many number of wickets he or she took in the past few matches. Yeah. So if you see, we don't have any labeled here. We only have score and wickets for like let's say for around 10 player, we don't have any specific label that so and so player is good at achieving score, or so and so player is good at is good at taking wickets. So I don't have any unique classification label throughout this data set. So in that case, what we will do, we'll apply an unsupervised machine learning model. One of the famous machine learning model is clustering. Unsupervised machine learning model is clustering, where what it does, it divides it divides a data into number of cluster. So I have wickets on x-axis and runs on y-axis, and I have two clusters. So if you see in cluster number 1, in this cluster, all blue dots, all the players which are present in that particular cluster, they have achieved more runs and took less wickets. Can you see that? And in cluster number 2, all the players have achieved more. They have taken more like more number of wickets, and they have scored quite a low runs, which means I can say my cluster number 1 is for batsman and my cluster number 2 is for a bowler, and I'm acting on unknown data, unlabeled data, and that is all about unsupervised machine learning. Next we have is reinforcement machine learning. It works on principle of feedback. So basically, I will give you an example to understand reinforcement machine learning in detail. Let's say I have my younger brother who is just like within first standard and who want to learn the bicycle. And now I have been appointed as a trainer for him. So trainer means a guide. Trainer means a guide, and reinforcement machine learning is based on guide based system. There has to be one guide who will who will guide the internal model to perform decision making. Now in this scenario, I am the guide to my brother, so that I can train him. I can I can guide him to manage the balance, and to how to do a pedaling and everything to the bicycle, right? So through the entire process of cycling, I'll have to judge him, I'll have to guide him, and I will be giving positive and negative feedback to my younger brother, so that he will become a good good at cycling. Yeah, same goes with reinforcement learning. There is one guide there, or we can say agent. Agent keeps giving a feedback, like positive feedback or negative feedback to the internal model, and accordingly the learning layers in the model will adjust themselves and will give you the best outcome in the output. So that is about a reinforcement machine learning. So we have seen three: supervised, unsupervised, and reinforcement machine learning. Reinforcement machine learning is also called as an award-based learning model. This is the flow of machine learning. We have input, we have model, we have output. So input is training data. Based on that, we'll develop a model, and then we'll get the output accuracy when we'll perform the testing. Now I have a quiz for you guys. I hope I'm clearly audible to all of you, and you are seeing my screen at better resolution. Yeah. I have a quiz for you. I will be showing you three scenarios. Three scenarios, and you have to recognize that that the given scenario belongs to which category, supervised or unsupervised. The note for this is, I'll not be showing any scenario for reinforcement machine learning. I have three scenario that is either a supervised or unsupervised. Now you all can access your chat box to write down your answer. Yeah, so let's go ahead. Scenario number 1 is, I'm clicking a selfie picture with all of you, and I am uploading that picture on a Facebook. So Facebook is automatically going to tag all the clear faces in that picture with correct user name. Let's say Suraj Gavande, then Tanaya Hinduja, and Jayashree ma'am, and so on. Yeah. So Facebook will automatically tag those faces, those clear faces, with the correct label in the output. Now you let me know, guys, is it supervised or unsupervised? I'm waiting for your answer in the chat box. we can access the chat box or not. I'm not sure in this meeting because I cannot see any option for chat box. Okay, you can unmute, like randomly you can unmute and you can let me know. Okay, I'll start with Abhishek Gaurav. If he's available, you can unmute yourself and you can let me know which scenario it could be. Let's make it interactive for a while. Yeah, Abhishek, are you here? Are you listening me? Am I audible?
Yes, sir.
Yeah. So is it supervised or unsupervised?
Supervisor.
Right. It is supervised. Why supervised? Can you give your logics on that?
Uh,
Any raw answer I'm expecting. Don't go too technical.
just a guess. I
Yeah, just a guess, and your guess is right, right? Anyone else who want to explain why it could be supervised? Like Abhishek, if
Sir,
you
it is supervised.
hmm.
Yeah, sir, because it is supervised because we have sets of images like whether it is face or not, it labels the data.
Yeah,
Yeah, so we can predict whether the image is face or not by capturing it. And also, I guess it uses LBPH face recognition algorithm, so it
yeah.
is supervised.
Yeah, a very simple answer. Why do you supervise? Because we all have accounts on Facebook, me and all everyone present in the meeting. So Facebook knows that if I upload my picture, it has to be a Suraj Gawande because it applies a face recognition, algorithm which is based on machine learning. So that's the reason why if I don't have an account on Facebook, Facebook may not be able to recognize me with my correct label. So it's a supervised machine learning. Moving on. Scenario number two is a Netflix movie recommendation. We can consider any app. It could be your Netflix, Amazon Prime Video, the Hotstar, like whatever you consider. What happened if I'm watching a web series on Netflix, which falls under some category, let's say a haunted web series, for example. I'm done with my web series, but after 15 days, a new web series in the same category comes up on the Netflix. Now that time, Netflix will give me a notification, a recommendation that there is something new to watch under so and so category. Would you like to have a look at it? That's a recommendation is done by Netflix app to me. So now you let me, is it supervised or unsupervised? It had just given me a recommendation. Anyone can randomly unmute and let me know. So Karan and Abhishek are done. Apart from them, who else want to give an answer? Is it supervised or unsupervised? It is simply
Sir, unsupervised
yeah. Why?
because it will not require the label data for the pre-processing.
Exactly. It's a simple recommendation. So basically, it is going to analyze your past search history, the pattern out of those search history, and it will recommend you something. So whenever we find a recommendation notification on internet or in some app, those are based on the unsupervised kind of workflows. Even like for example, if I'm searching for a shoes on a Flipkart in my internet online. So if I close down that tab and opens a new tab of Facebook, somewhere in the corner, on right hand side, it pop up a notification from Flipkart and with the same brand that is shoes. So that is also a recommendation system based on supervised machine learning algorithm. Now third scenario is fraud detection. I give you one scenario. Let's say we have a bank, like we have a main branch of State Bank of India in Pune, and they have their own IT server. So they have an IT team who is continuously monitoring the transactions which are happening across the Maharashtra. So they have one bank server, they have some screens and everything. They have a complete setup, and IT people are only going to monitor, observe the transaction which are happening online. Now, if they feel some transaction may have some, suspicious activities done, they will provide that transaction data, whatever they have, to the financial analyst. And financial analyst supposed to act on that data by applying some machine learning model and to come up with a decision. It could be a fraud transaction or a safe transaction. Sometimes what happens, we try to put the pin for one or twice or thrice, and it didn't take, or sometimes we by mistake and we give a wrong input. So that data will also go on bank server, and we get a notification. Somebody, are you the one who is trying to enter into the SBI app, for example? We all have got this message once for once in a while, like if you have done like that. So now let me know, this kind of like, if I want to act on this data, this transaction data, which machine learning model I'll apply? Is it going to be a supervised or unsupervised? Yeah.
So unsupervised.
Yes, it will be unsupervised. Who told that answer? Can you tell me your name?
Current.
Current. Okay. So current is right. It is unsupervised. So for such scenarios, we have to apply unsupervised, framework. So that is all about machine learning. So I have just tried to, give you the glimpse of real-time examples. Even Ola and Uber apps are based on machine learning. They give some, they have designed such a way that they give you the uh, updated fare details. They will make a car available to you based on the location, time, and then there are some criteria that we will discuss. So, like, first of all, they will find out the location you are standing in. Suppose I'm standing in Shivaji Nagar bus stand, and obviously that's a very no very busy area, 24/7, for example. Then from my origin to with a diameter of 4 kilometers, they will give priority to the four parameter, that is demand of the car in that area, number of cars available, bad weather, and rush hour. So if demand of the car is high, we'll say 1, number of cars available are 1, sufficient cars are available. Bad weather is 0 and rush hour is 1. In that case, car will be available to you, but with some increase in the fare. But if demand of the car is 1, number of cars available 1, bad weather 0, rush hour 0. In that case, the fare will slightly decrease. So accordingly, that app will make the prediction and will give a car available to you with the fare details and all. So fare will keep changing based on this parameter. So that is how this taxi giants are based on the machine learning approach. So I have tried to give you an overview and the concept of machine learning model. Now we'll move to MATLAB and we'll understand how we can implement this machine learning model in real time, and how we can take them ahead on hardware like Android phone or Arduino or desktop or Raspberry Pi, using MATLAB and Simulink without writing a single line of C code. So that's the interesting stuff in MATLAB, that we can convert MATLAB into C++. We can also integrate with Python. We can call Python command in MATLAB. We can call MATLAB command in Python. So the two-way communication is possible. Since MATLAB is giving you a very good graphical user interface, we recommend you to go with MATLAB. You can integrate with Java, .NET, C, C++, Python. All these open source application, and you can develop your model quite interactive. So this is the MATLAB 2020B user interface, which is the latest version of MATLAB, having MATLAB and Simulink as a basic platform. And on top of that, we have around 105 models which are there for targeting various applications. I will take you through the desktop. So if you type doc on the command window, you can go through the MATLAB documentation. We have a MATLAB coder. We have a code generation support with MATLAB and Simulink, which converts your MATLAB or Simulink model into various languages like C, C++, HDL coder, embedded C, and so on. Which means I can simply, by using a USB cable, I can connect Raspberry Pi with my MATLAB, like with the machine on which I have installed MATLAB. I can connect Raspberry Pi. I can connect Arduino or Android phone, and I can deploy any MATLAB function or Simulink model very easily on the hardware to have a real-time analysis. So that is how MATLAB gives you a very flexible platform where it totally eliminates the stage of writing several lines of C code for embedded hardware. So if you use embedded coder, it generates optimized C and C++ code for embedded hardware. Similarly, we have GPU coder. So GPU coder converts your MATLAB program into a CUDA code to accelerate the performance of GPU. So which means if I'm running a very heavy deep learning model on huge amount of data, so instead of doing the training of deep learning model within CPU environment, I can take that on GPU, external GPU, which is connected to my machine. And once the training is done on that GPU, I can take those results back in MATLAB to visualize and to understand. Similarly, if I have some FPGA devices like Spartan and Xilinx devices, I can go with HDL coder because it converts your MATLAB into VHDL Verilog automatically. So I don't need to worry about what could be the C code for my MATLAB function or simulating model. With simple few commands, you are able to deploy, you are able to take your MATLAB design on hardware in real time. And that is about a code generation using MATLAB. Likewise, we have several modules available, and we have data science and deep learning vertical where we have deep learning toolbox, deep learning HDL toolbox, predictive maintenance toolbox, reinforcement learning model, standard machine learning, and text analytics toolbox. So text analytics for natural language programming, statistics and machine learning for implementing various supervised and unsupervised machine learning algorithm, reinforcement learning for award-based learning model, predictive maintenance for hardware. Plus, if you want to predict maintenance of huge machines, those are typically used in the automotive and electrical industries. So the maintenance cycle of the machines can be predicted by using machine learning. So that's all about predictive maintenance toolbox. You can also calculate the remaining useful life of so and so machine, so that the maintenance engineer can understand and can provide the maintenance to one part or to the entire model. We have deep learning where we can implement convolutional neural network and various recurrent neural network by using deep learning toolbox. Yeah, that is all about data science and deep learning vertical. Today we are going to implement machine learning model using MATLAB. So for that we have to first of all import database. So let me check for browse. Let me click on browse for a folder, which means I'll be changing my active directory to get data. So I'll go to the folder where I have my data present here. So I'll have data present in standard machine learning toolbox. So I'll just click on select folder. So I'll make it as my active directory. And as you can see, I've got fisheries data. So I'll be using fisheries data for this implementation. Now to import Excel file or .csv file or image or video, we have one simple tool called import data. So once you click on import data, which will be taking data from active directory itself. So now right now we are at this folder. This is my current directory, right? So you can see I have image, I have text, I have Excel sheet. So all types of data this single tool is able to recognize. And if you want to understand what all data file it recognizes, then you can go through this particular format. I'm going to use fisheries data, so I'll import it by clicking on open button, and in next step it is going to open the import wizard application, where we'll select how many rows and how many columns we want, and what should be the data type of that particular variable, which will be going to MATLAB import workspace. So yes, we got this fisheries data. It's still loading. Once it is done, we'll go ahead with data import. So that's how we can import data in MATLAB environment. Yeah. So if you see in this data set, we have total 150 samples, and per sample we have 5 column, and out of 5 column, initial 4 column are the input features. They are sepal length, sepal width, pedal width, and the last column is the species column. That is basically a output column. So here I'll say a numeric matrix because I want all the I want only the numbers. I want only a quantitative data on which I'll be acting on. So I'll say data. Sorry, yeah, data, and I'll go and import. Now this is a ready-made tool for data import, isn't it? So if I want to see the code behind, I can go to generate script option, which will generate a MATLAB code in the backend. I'll close this. Now I'll moving on for splitting this data into training and testing. So if you see, if I double click on this data variable, I'm able to see the insights of data where my data is sequentially arranged because 1, 2, and 3, we have 3 numeric unique classes throughout this data set. But one basically belongs to a Setosa type of class, yeah, and yeah, 2 belongs to a versicolor, and 3 belongs to a virginica. These are the 3 classes that we have for this data set of fisheries. Yeah, these 3 classes. So now we have to, if you see this data set is not randomized, all samples are sequentially arranged, first 1, then 2, then 3. Now we'll have to randomize data. So I'll consider one. I'll first of all create one blank matrix with all 0 elements. So I'll rename it as capital D, and I'll create one matrix of zeros, and I'll provide a size will be of data. So I've got a matrix with all 0 element here. उसके बाद I'll have to generate one random array. So I'll use a command randperm. So RANDPE it will generate a random permutation of numbers. Will provide total 150 numbers. So it will generate random number in the range of 1 and 150, which we will be using as an index for randomizing data. So I have R here. If you can see, I have got 123, 99. So the minimum value is 1 and maximum value is 150 for this data. Now I'll call a for loop. For I is equal to 1 colon 150 here. That's my range, right? And then I will have a capital D. Capital D में data कैसे जाएगा? Row में, because all samples are arranged in row format, isn't it? So I comma 1 colon end. 1 colon end लिख दो आप, या फिर you can write simply a colon, or you can write 1 colon 5. फर्स्ट रो में, मतलब फर्स्ट रो में क्या, सी मैटलैब में ऑलवेज इंडेक्सिंग स्टार्ट्स एट 1 नॉट एट 0. या like in other programming languages the indexing starts 0, but MATLAB follows the mathematical the base is mathematics, the base is matrix, and matrix always starts at 1. So that's why in MATLAB the indexing always starts at 1. Just remember that. Then is equal to, so d of 1 comma colon means, because for all 150 samples, no, these columns are fixed, so anyway they are not changing, so that's why I'm saying colon. Otherwise you can write 1 colon 5 as well. So I'll write d of I comma colon is equal to, अभी डेटा कैसे जाएगा, डेटा जाएगा डेटा में से, so data I simply write data of I comma colon, then first row from data will simply go to capital D. Yeah, so it will not, it will not perform a randomization. So to have a randomized data, we'll have to write R of I colon, and then simply end. What will be the R of I? R of 1 will be 123, 99, which means 123rd row of data will become a first row in capital D, and that's how we are randomizing. As you can see on my screen, we have randomized data very properly. Now we'll go ahead with splitting this data into train and test. So I'll say TRD is equal to a capital D of, I'll take around 120 samples for testing. So I'll simply write 1 colon 120 here, comma colon, and I'll execute this statement. So I'll get 120 samples for training. Rest sample I'll be taking for testing. So I'll write TST is equal to capital D of 1 to 1 till end, that is 150, comma colon. Yeah, and I cannot write colon because the test data should be an unknown data, so I'll write only 1:4. So TST is my only the input attributes, and the output, the output classes for output classes of TST I consider into Y. So Y, we can say Y predefined. Yeah, Y predefined is equal to your output variable should be should be relevant, so that you can understand कि ये output variable किस चीज के लिए हम use कर रहे हैं हमारे code में. Y predefined is equal to capital D of 1 to 1 till end comma 5. So my label column has been has been copied into a new variable, that is Y predefined. So this Y predefined is the label column associated with TST, and TRD is totally independent data having both the input and output. Now we will go to apps. Instead of writing line by line code, I can use apps so that I can get some interactive platform to implement my machine learning model. So I'll go to so I have various apps present. So I have machine learning and deep learning vertical there. So in deep learning and machine learning and deep learning, I have classification learner, I have deep network designer, various apps present. So I'll say classification learner because it allows you to train model to classify data using supervised machine learning. Apart from that, we have so many apps which you can try out at your end. Documentation is available online, offline as well. So I have this classification learner tool. I'll have to first of all click on new session. So the data is available from workspace. So I'll say workspace here. After that, we'll select input. So input is my TRD, and I'm not going to apply any validation method because I may not fill a data overfitting problem just for 120 samples. And column number 5 is the response column because it consists of all the outputs. It consists of labels, and a column number 1 to 4 are the input attributes. So I click on start session. So the data will be imported to this app, and that will be visualization is done in a scattering plot, and color codes are defined here that blue is class 1, red is class 2, and 3 is like yellow is class 3. You can change this from this option. You can change the data visualization in this format. After that, if you want to perform feature selection and feature transformation, these options are available, but I'll straight away go for a classification. So I'll use one supervised machine learning model. So I'm going to use support vector machine. That's a supervised machine learning model. Apart from that, you also have available nearest neighbor classifier, ensemble classifier, a naive bias, logistic regression classifier, discriminant analysis, and decision trees as well. I'll say quadratic SVM here, and I click on train button. So train button will take that network through training process and return a training accuracy in the output. So we are getting 98.3% accuracy, and let's check how many samples are misclassified out of 120. So out of 120, 2 samples are misclassified, which means the original class of this sample is a true class is 2. It belongs to red, but it misclassified as 3, that is yellow. Similarly, we have we can check for remaining class. Yeah, just a second. Yeah. So for this class, the true class is 2, same, that is red, but it is misclassified as class 3, that is yellow color. And similarly, we can check for confusion matrix. Confusion matrix has to show you 2 sample misclassified and rest of the sample classified, and it will give you the classification accuracy as well. So we have got, see, we have like 37 samples for class 1 out of 120, so 37 out of 37 are correctly classified. We have 40 samples for class 2, so 40 out of 40. Sorry, we have total, yeah, 40 out of 40 are correctly, we have total 42 classes, so for out of 42, 40 samples are correctly classified and 2 samples are misclassified as class 3. And for class 3 we have total 41 samples, so 41 out of 41 samples are correctly classified. And after that we can also check for confusion ROC curve, and in the end if you go, we can generate MATLAB code for support vector machine. At the same time, I can export my model to MATLAB workspace with a name, or you can change the name as well. So as of now, the name is trained model. Yeah. And now to perform classification on a new sample, we have to use this particular command. So we know that we have a samples, a testing sample present in TST. So I'll write TST here. TST of, let's give a third sample. All colon means all column, or you can write 1:4 as well. And it gives you a class. So model is predicting that so and so sample belongs to class 1. We'll compare yfit. We'll compare yfit if equal to y. Now I can type tab key to get the complete name of is not working well, so that's why I'm getting such a result. Oh, sorry. So let me type the whole to y predefined. Please, oh, sorry. Y predefined of logical 0. Which sample we have used? 3, right? So we'll have to compare third sample only. So logical 0 means it is not matching, the result is incorrect. So if I say 3, it's logical 1, which means what we have observed using machine learning model and what we have in predefined, those both results are matching, and that is how we are achieving the 100% accuracy for class 3. Similarly, we can take counter and we can check for all 30 samples in TST. So I'll just write for I is equal to 1:30. Then I'll run this command and here I'll put I. Then if your y fit matches with y, define of I, then my counter will be increased by +1, and if is end and for is end, I'm getting total 29 sample correctly classified out of 30 by using a quadratic support vector machine, and I'm achieving 97% accuracy out of my model by getting 29 sample correctly classified. So that is how we can implement machine learning model using classification learner app, which is a part of statistics and machine learning. Similarly, you can explore more of these apps to understand more about machine learning and deep learning. And if you also want to understand how to integrate with third-party languages like Java, .NET, and if you want to add static libraries or dynamic libraries in your code, you can go to the documentation of MATLAB to understand more about the external languages interface. So external language and library interfaces including Python, Java, C++, .NET, and web services. So similarly, we can also perform deep learning using MATLAB. For that, you need a deep learning toolbox. So you can explore this deep network designer app for more detail. Yeah. So that's it from my end. I request all the participants to go ahead with your queries if you have any on this. So one by one, you can unmute yourself so that we can discuss the query for rest 10 minutes, and then we'll wind up the session. Oh, I'm sorry. My official email ID, you can get back to me on my email ID for any details regarding this. You can take the screenshot of this. Let me increase the font size. I just forgot to increase that. I'll have to go to preferences here, and I have this fonts option, custom font. So command window ka I can go to custom. I can make it to 12, which is better. Yeah. So I'm done with my content. I hope it was informative session for you guys, and I hope you have learned how machine learning, how MATLAB can be used machine learning platform, and since you have an integration with Python as well, you can use this rich, better interactive GUI for machine learning, because even if you explore this plot, it offers you n number of options for data plotting. Yesterday, Milin might have covered this topic on data visualization. So I'm moving my screen to the meeting now. I want to hear out from you. I want to know that if you have any queries, please go ahead.
Participants are
Hello, sir.
requested to raise their hand before asking a question, please,
Yeah.
so that we can keep a track. Okay, Karan, you can go ahead with your question.
Hello, sir. Thank you for this informative session. Sir, actually, I had one doubt that how can we label our data according to algorithm we want? Like, if you have to use KNN or regression, linear regression or quartile regression. So, which approach can we go with depending on the
Mm,
data?
okay, so basically, if you want to work on labeled data, most of the data set are automatically labeled. But yeah, if you sometime what happens, we have a like like out of 100 sample, if you have only 40% data is properly labeled and this data is unlabeled, you can use a data augmentation method for that, for labeling your data set. So which will create which will create a repetitive samples of your labeled data, so that you can increase the increase the density of your training data set. So that will be the one approach. Apart from that, if you have unlabeled data, you can go ahead with unsupervised machine learning model, and you said a regression, right? So for regression, most of our labels are continuous varying. They are not independent labels. So examples like temperature forecasting or weather forecasting. So in regression, we perform on a label data set, but where your label is a continuous label. So data augmentation method can be used for that. That is one of the method.
Yes, sir. Sir, also I had one doubt. Like we can use TensorFlow on backend with CUDA, right?
Yeah.
So,
Yes. So
like,
yeah,
yes,
please
sir.
go
Yes.
ahead.
Sir, so like we can use TensorFlow in backend with CUDA, so it can like replace the GPU consumption and all. So why
Yeah.
can't we directly use Colab? Like it doesn't consume GPU and it can
Which
just
app?
train models. Google Colab.
Google Colab. I'm not sure if you can use Google Colab in MATLAB, but yes, we have facility to import the, TensorFlow framework in MATLAB. Even we can convert Python, MATLAB code into the code which are supported by TensorFlow framework by using a open neural network exchange format, O converter we do have, and for GPU we have a GPU coder, so we can accelerate them by using that. I'm not sure about Google Colab. I need to check on that.
Thank you, sir.
Yeah. Thanks, Karan. Anyone else? You can raise your hand, like Sudesh said. Jayashree ma'am is in the meeting or she left?
She is still there. I guess so. But
Yeah,
yeah,
ma'am.
ma'am is on hold.
On.
I guess she's
Yeah,
also attending the other meeting.
yeah, yeah.
Yes. That's why she is not responding. The participants, are there any other questions?
Sir, I had one last question.
Yeah.
Sir, like without any GPU, can I use CUDA to run and train my models?
So basically, I tell you, in MATLAB, when I said CUDA, which means I have a GPU coder. Which, so if you want to use external GPU or the inbuilt GPU on your laptop, and if you want to dump everything on a GPU instead of CPU, then in that case, the GPU coder will come in picture, which will convert your MATLAB code into CUDA. So that is all. So definitely you can convert your MATLAB into CUDA, a CUDA code, even though you don't have a GPU. So that is what it
So
is.
like,
Mhm.
okay, yes, sir. Got it. Thanks a lot, sir.
Yeah.
Anyone else? Any question?
Should I conclude the session then?
Oh, wait, guys, there are no more questions. Okay. Okay, then Tanya, we can move ahead with the vote of thanks. Tanya, over to
Yeah.
you.
So thank you, sir. I would now like to offer a
Tanya, please
yeah.
keep your camera on for the recording.
Okay. One sec. Is that fine?
Yeah, go ahead.
So, thank you, sir. I would now like to offer a vote of thanks on this occasion on behalf of MESCO IIC and our department workshop team. I would like to extend my gratitude towards the management of Modern Education Society, Dr. Joshi ma'am, Dr. Hake sir, and Dr. Savade sir, the principal of MESCO, for encouraging us to organize such an informative workshop. I would also like to thank Sir Suraj Gawande from Design Tech Systems for sharing his knowledge with all of us. I would also like to express my gratitude to our HOD and our President of IIC, Dr. Sheikh ma'am, and Vice President, Dr. Dale ma'am, Dr. Mitra sir, the convener IIC MESCO, for encouraging this workshop, for encouraging us to arrange this workshop. I would also like to thank Dr. Pansare ma'am for the innovation coordinator, Raska ma'am, department workshop coordinator, and all members of the workshop committee for their continuous support to carry out this event. And last but not the least, all the participants of today's workshop, thank you so much for your patience and active participation. I would like to conclude this session on this note. Thank you, guys.
Yes, so please don't leave the meeting. We need to first take photograph. So Gajanan sir, are you there?
Sudesh, I'm here.
Suraj sir, you are also requested to keep your camera on. Gajanan sir also, yes. Hello. Yeah. Tanya, you also keep your camera on.
Even rest of the guys can make their camera on.
Yes, sir, we can go ahead with that as well. So participants are also requested to turn on the cameras. Only, okay. Mihir is here. Amit is here. Okay. So, okay, Ghanshyam has turned on the camera. Okay. सर ते लार्ज गॅलरी मोड ऑन करू का?
हो चालेल ना सुदेश.
उगाच मोठे पण ट्राय करून बघू, त्यात पण एक फोटो घेऊ.
हम्म.
ओके ग्रेट. ओके होल्ड ऑन सर, घेतोय. Okay, sir, we can now turn off the camera.
Thank you, Sudesh. Thank you very much, sir. Thank you very much, Suraj, sir. It was very nice and informative session of yours, and our students definitely will get benefited from this.
Yeah, thank you, sir. Thanks. Bye,
Well,
everyone.
okay, sir. Welcome. Sudesh, can we end the meeting? Everything is done. Stop the recording. Stop.
Yes, sir. Yes, sir. Just a second. I have not stopped the recording. I will stop it.